Hello everyone, I hope everybody is fine and ready to learn more about trigonometric graphs. We want to draw the graph of this sinusoidal function. The equation is y equals -3 cosine of x minus pi over 3 plus 1. We are going to draw this graph, the graph of this function, which actually is a cosine function that has undergone so many transformations, but we're going to draw this in one shot using a special method with 5 steps. So in the first step, we are going to identify the properties of this cosine function. How can we draw the graph of a sinusoidal function without even knowing what the amplitude is, where the function is defined, what is the max value, what is the phase shift, what is the period of the function? If we don't know any of these pieces of information, how can we draw the graph of the function? So step one is to identify the key properties of the sinusoidal function. Amplitude of the function here, the amplitude, many students by mistake they say the amplitude is -3 because that's the a value, but in fact the amplitude can never be negative, and it's actually the absolute value of that so-called a coefficient of cosine. So the answer is +3. So the amplitude is 3. The period is always found by the formula 2 pi over k. In this case, k is equal to 1, so it's 2 pi over 1. So it's going to be 2 pi. If there was a coefficient like 2 or 3 here, the answer will be 2 pi over 2 or 2 pi over 3 radian. The phase shift in this case is pi over 3 radian. That is the amount of horizontal shift, and it's to the right. Direction is to the right. So pi over 3 is the amount of horizontal shift known as phase shift. Is the magnitude, is the size of the horizontal shift, and the direction is to the right because we have x minus pi over 3. If it's x plus pi over 3, it will be phase shift of pi over 3, and then it will be to the left. Max value here, to find the maximum value, we can use either the formulas or you can say that cosine has a minimum value of -1 times -3 is going to be +3 plus 1 is going to be 4. So the maximum value is 4, and the minimum value is -2 based on the formulas studied in the past. So we know the max value, we know the mean value. Equation of axis of the curve, we can look at the 1, the value here that is added. So it will be y equals 1, which is showing the amount of vertical shift up by 1 unit. So step 1 finished. We identify all the properties of the function, max value, mean value, all of that. Step 2 is to select an appropriate scale for the x and y axis. So here on the x-axis, I have selected a special scale. So every tick mark on the x-axis represents pi over 6 units or 30 degrees. So 1 square on your graph paper on the x-axis represents pi over 6 units. So 2 of them would be pi over 3 radian or 60 degrees. 3 tick marks would represent 90 degrees or pi over 2 radian, and so on and so forth. So 2 pi, which is the period of the function, I think there would be how many tick marks? So 12. There's going to be 12 tick marks from 0 to 2 pi, okay? Because every tick mark, every square on the x-axis represents pi over 6. And you can select anything you want. There's no right or wrong answer. It's just a matter of appropriateness and inappropriateness in selection of the scale. Otherwise, there is no right or wrong. The thing is that sometimes if you select an inappropriate scale, your graph will be something like this. Like it's going to be extremely narrow, or if you pick again another inappropriate one, you're going to get something like this, which is like almost a straight line. It doesn't show that curve of a sinusoidal function. So you want to end up with something that is like sinusoidal, or it has a wave shape. Therefore, if you select an inappropriate scale, too large, too small, it's not going to look nice. Otherwise, it's not a question of wrong or right. So we have to choose something appropriate, basically. On the vertical axis, I selected one tick mark to represent 1 unit. So 1 square is 1 unit. Sometimes you can select 1 square to represent half a unit. So 2 tick marks would represent only 1 unit. So depending on the question, depending on the equation of the function given, you can select different scales. So that was step 2, selecting an appropriate scale. Step 3 is to draw the max mean lines. So maximum value is 4, minimum is -2. So I know that y equals 4 is going to be the maximum line here, and y equals -2 is going to be the minimum line. Okay, so these are two horizontal lines that sort of show us the borders of the upper and lower borders of the sinusoidal function. We know that whatever action is happening in between these two lines, and there's no graph that we need to draw above y equals 4. No part of the graph will be below y equals -2. Whatever we need to draw, whatever graph does exist, it's happening somewhere between these two minimum and maximum lines. And of course, right in the middle, we have this y equals 1, which is the axis of the curve. So it is happening at 1. So right in the middle, so y equals 1. That's axis of the curve. And that is step 3, drawing these lines so that we know over what, domain or borders, upper lower borders, we are working. Step 4 would be plotting 5 key points. Okay. Now, in case of a cosine function, the key points are these points that you have already studied in the past. So we start with the maximum point, and then we have a point on the axis, and the minimum point, another quarter point, and then again back again to the maximum line. These are the 5 key points in case of a cosine function. But if you have a sine function, you start at the at the axis of the curve, and then you go to the max, again axis, minimum, and then axis. These are the 5 key points in case of a sine function. And if it's like a negative cosine function, which we have the case here actually, then instead of starting from the maximum line, you are going to start from the minimum line because of the reflection in the x-axis that is happening. And if it's like a negative sine function, instead of going up, you're just going to go down. And this is how the graph will look like in general. And the 5 key points must be found from there. So this is a negative cosine kind of function. So I know that I should start from the minimum line, somewhere on this line. But where? So I'm looking at the phase shift now. The phase shift, it says pi/3 to the right. Okay. So pi/3 to the right. So negative cosine function normally starts on the y-axis right here, but right now I have a phase shift of pi/3 units to the right. So I have to go 2 units to the right, and that is the very, very first key point I plot. This is the very first point on the graph that we plot. How did I know it's on the minimum line? Because it's a negative cosine kind of function. What if it was positive cosine function? Instead of here, I would start from the maximum line. Very simple. What if it was a sine function? I would start from the axis of the curve. That would be like the first point I plot. I told you earlier, didn't I? And why not on the y-axis? Because there is a phase shift involved. If the phase shift was 0, then I would not shift the graph to the right or the left. I would just start from y-axis, where it is originally started. But now, because I have a horizontal shift to the right by pi/3 units, the phase shift is pi/3, so I have to start from this other point under pi/3 and on the minimum line. Okay, so that is the first of the 5 key points I'm supposed to plot, and I did plot it. Now, the next point after this point, I'm going to go after the one that is at the far end. So I did this first, and then I'm going to do this one. That's number 2. And that is by the amount of period, like period is how much? Period is like 2 pi. So by the amount of 2 pi units, I have to move to the right from this single point to plot the next point. So 2 pi is right there. 2 tick marks to the right of it, it would be 14 pi/6 or 7 pi/3. So this is exactly 7 pi/3. That's 2 tick marks after 2 pi. So from here to here is exactly 2 pi units. It is supposed to be because the period is 2 pi. I started at pi over 3. I ended up at 7 pi over 3. Okay, so which is 2 pi plus pi over 3. Okay, the next point would be the middle point. So in between these two, if I count the tick marks, there's 12 tick marks. Half of 12 is 6. So I start from here, I count 6 tick marks, and that is the middle point on the maximum line. So I go 1, 2, 3, 4, 5, 6, and that's exactly where I'm going to be. It's 8 pi over 6 or 4 pi over 3 actually. 4 pi over 3. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. Okay, so that's the third key point I plotted, 1, 2, 3. And now the fourth one and the fifth one are going to be the quarter points. In between the first and second point, we have like 6 tick marks. Half of 6 is 3. So I go 1, 2, 3 tick marks, and I'm going to be right here. And then after that point, again, 3 tick marks, 1, 2, 3. It's going to be right there. And these are the 5 key points that I plotted. The 2 last ones are the quarter points. Okay, so now it's time to draw a smooth curve passing through these points, and we know the general shape is like sinusoidal, wave shape kind of curves. So this is going to be the approximate shape of this graph. That's how it's going to look like. Okay. And the thing is that usually we draw 2 complete cycles, or maybe they give you an interval. They say draw this graph from 0 up to 4 pi, or like from negative 2 pi to positive 2 pi. Either they give you an interval, they say graph it within this interval, or they say just draw any 2 full cycles of the graph, from wherever you want, So now I'm thinking I can extend this to the right, or I can just extend this to the left. I can do either way. So let me increase the size of the x-axis here a little bit, because I may need more. So 1, 2, 3. Okay, so we know that 12 tick marks. So from here, 12 tick marks. If I move forward, that's going to be the end of the other cycle, the second cycle. So we were at 7 pi over 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's exactly here. And then if I count 1, 2, 3, 4, 5, 6, that's exactly where the top is. And then if I count 1, 2, 3, that's the quarter point. From there, 1, 2, 3, that's the quarter point. 1, 2, 3, perfect. So I plot, I replicate the points basically, and then I draw the next cycle, with some sort of semicircular graphs at the top. Some students join these points with a ruler, draw a straight line, which is completely wrong. You should be doing that. So this is the first cycle from here to here. So that's the one cycle of the graph, and this is just another cycle. So we have graphed 2 cycles of this cosine function. Of course, I could have drawn the cycle on the left-hand side. I'm not saying no. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This will be the next point. 1, 2, 3, 4, 5, 6. So that would be the next one. And then 1, 2, 3. This will be the next. Then 1, 2, 3. This will be the next. So I would end up with another cycle. If I wanted to draw the cycle on the left-hand side, I could have done it. It would look like this. Okay, so all I'm doing is just replicating the first cycle that I did have. Okay, so step 4 was plotting the 5 key points, and step 5 was drawing the graph and replicate it as necessary. We just copy this graph on the right side, on the left side. If we have to draw the graph from negative pi, so I'm going to stop here. I'm going to erase this part from negative pi up to, let's say, 4 pi, or whatever interval given. They say graph within this interval. We can just draw only within the given domain, or if they say draw 2 complete cycles or 3 complete cycles, whatever they say, we just follow the instructions. Here I have drawn 3 complete cycles. I didn't have a graph paper, mind you. You have to do these very accurately on a graph paper, and I'm sure your graphs will look much nicer. So these are the 5 steps that we can use to draw the graph of a sinusoidal function. And mind you, at the end we have to, of course, label the graph of the function. Let's not forget to label the graph. And we label the maximum line, minimum line, axis of the curve. Everything is fully labeled. And this is how you draw the graph of sinusoidal functions. You need to practice a lot, maybe 3-4 hours at least. Spend time learning how to draw the graphs of these sinusoidal functions. Remember, if it was a sine function, 5 key points will be found differently. If it's cosine function like this, of course this was negative cosine, but if it's positive cosine, you start from the maximum point, not the minimum point. These are the little details you have to pay attention, and by practicing and gaining the experience, you're going to become better and better at it. But it certainly requires to put the effort, time, and energy, and you have to spend the hours so that you become very, very good in graphing. Thank you very much for your attention.